Here we have subsets. Set A as a subset of set B if all elements of A are also elements of B. In this case, we're going to use this one. So this is subset. That symbol is for subset. And we're reading from left to right. So A is subset of B. I'm going to have example for this one. So let's have, for example, for set A, I have A, B, C. And for B, I have A, B, C, D. But I want to see if this A is subset of B, meaning that I should have all these members that are in set A, all these should be inside B. So I have A, B, and C, and it doesn't matter if you have more than that. We only want to see if all these members in A are also in B. Since they are, that means that set A is subset of B. What this one means, A is subset of B and A equal to B. This one means equal to. But the point is that since we have this D and I don't have that D here on top inside set A, that means that here in this case, we don't have A equal to B. Because A equal to B, that means we should have exactly same elements. I'm going to have that later. And I'm going to explain more this one because the first is sometimes it's complicated. Every set is a subset of itself. That we always have this one. Obviously, if I use the set again, all these members that we have inside A are inside A. So that is the what this one means. This note, every set is a subset of itself. And empty set is subset of another set. Not just A, it doesn't matter what set we have. Empty set is subset of any other set. The third one, set A is proper subset of set B if all elements A are also elements of B, but A is not equal to B. See, this was the one that I was trying to explain here on this example. So in that case, when A is not equal to B, that means that we have this symbol. We don't have this equal to here on this part. Now that we know that, what that part is, since I do not have exactly equal to between A and B, that means I shouldn't have this equal to for this part. If I want to have that one, changing this example, for example, A, B, C, and B is A, B, C. We do have exactly same members. So A is equal to B. And also, all members that we have inside A are also inside B. So in this case, A is subset of B, B is subset of A, and A is equal to B. So we do have all these for this part. So we had this symbol, and this one was proper. Proper subset. But if I have this one here, that is equal to, so our sets should be exactly the same thing. In that case, we will not have proper subset. Instead, we have to say that this is subset. Okay, so the first one was subset. We had this symbol. Then after that, we used proper subset, not having equal to. So that was the difference between subset and proper subset. Now the next one, number of distinct subsets of any set A is 2 to the nth power. So this is rule that we're gonna use always. The number of subset of any set is 2 to the nth power, where n is number of elements. So this NA is number of elements in set A, or cardinality. But the number of proper subsets, see, I had the first one was number of subsets was 2 to the nth power, but to find the answer for the number of proper subsets, what this one means, now in this case, we do not equal to. Since we do not have equal to, we have to subtract 1 from total number of subsets. This is the only difference between these two. 2 to the nth power minus 1 is to find the number of proper subsets. You have to remember these two on quizzes or on your exams. So that part is important. This one, this one. Now example 1, determine if A is subset of B, B is, so A is subset of B, B is subset of A is proper subset of B, B is proper subset of A is not equal to B, or A is equal to B. This one, subset. Same thing for this one. Here is proper. Both of these, this is not equal to. And this is equal to. Part A, our set is, here we have X such that X belongs to, so this one is belongs to, and is natural numbers. And X is between 1 and 7. Most probably you don't have this part, so add this one. B is X such that X belongs to natural numbers, and x is less than 8. So I added this. Now I'm going to write these two sets in roster form because I want to see what exactly the numbers are inside set. The first one, A. Here we have natural numbers and x between 1 and 7. Since we have equal to, we have to start from 1, and at the end, again, is equal to, we have to stop at 7. So starting from 1, 2, 3, 4, 5, 6, 7. And B, natural numbers starting from 1. So natural numbers, they start from 1. That's why here combining these two, we have to start from 1, but we have to stop because x is less than 8 is not less than equal to 8. So we have to stop here. But if you had x equal to on that part, you have to use 8. Now that we have these two in roster form, now we can compare set A and set B. Do we have exactly same members in set A and B? Since we have exactly same members, we have 1, 2, 3, 4, 5, 7, 6, 7 in both of these. That means that A is equal to B. And also A is subset, so we can use this one here on this part. A is subset of B. At the same time, B is subset of A. So we do have all these three. That is the answer. Now part B. Do we have all members that I have in set A also in set B? All members that are inside A have all these three here. We don't have this one inside A, so meaning that it's not exactly equal to, so A is not equal to B. So A is not equal to B, but A is subset of B, proper subset of B. We're not able to write this way because we don't have that one. We don't have equal to. So I'm not going to use that one here. B is not proper subset of A, but I don't have this symbol here on top. It's not asking if do we have this one here on top, so I'm not going to write that one. So B is not proper subset of A because of this member that is not inside A. The answer is this point. If we had this one, if we had equal to, and if we had this part, that means that our answer would be this one. The answer is A, proper subset of B. If you had that as a answer, clearly we can see that we don't have equal to it, so it's not equal to B. But here on this part, it's asking which one applies to each one of these. Because of that, that's why we're writing all of them. Now part C. Set A, we have A, B, C, D, E, F, G, but B is A, C, B, D, E. Let's start from A. Do we have all members that I have in set A also in set B? No, we don't. It's clear you can see that how many members we have in A. We have 7 members, but in B we have 5 members. It doesn't matter what members we have. Since we don't have 7 members, we don't need to continue and see if are these members exactly the same thing. So obviously A is not subset of B. But now let's use these members that we have in B. Are all these members inside B also in set A? We have all of these here inside A. These two sets are equal to or not. We do not have exactly same members, but here B is proper subset of A. Okay, the next one, part D. Set A, we have even numbers. With set B, we have natural numbers. Do we have exactly same set? We don't, because we don't have exactly same members and same number of members. We have infinite numbers inside each one. And do we have all members that are in set A also in set B? B is natural numbers. When we say set is natural numbers, that means that you have all odd numbers and also even numbers. So A, we have even numbers. That means that all the members that we have here inside A are also inside B. You see, that one is even, 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 even. Meaning A is proper subset of B, but it's not exactly equal to. And what about B? Are these all these members inside B? Can you find them inside A? No, we don't have odd numbers here in A. And okay, that's it. That is the answer for this one. Part E. Are these two equal to? No. And is A proper subset of B? No, it's not. Because we don't have odd numbers here in B. What about B? Is B proper subset of A? No, it's not. Because we don't have even numbers in A. So the answer for this one is that part. Because we don't have these symbols on top. That's why the only answer that we have here, choosing from what was given on top, is just A is not able to be. Okay, part F, I may want to add one more here on this page. Here A is 1357. So 1357. Not subset of A. So again, this one is subset, this is proper subset. So our answer for this one is that part. I'm going to add one more here for practice. So for part G, I'm going to have 1, 2, 3, 4, 5, 6. And for B, I'm going to have 2, 4, 6, 8. Now let's compare A and B. Do I have all members that are inside B at the same time inside A? 8 doesn't belong to set A. It's not inside A. Since we don't have 8 inside the other set, inside A, what that means is B a subset of A? Is B proper subset of A? Proper subset means you should have all these members inside A. I don't have that one. I don't have this one. When I draw a line like this, that means it's not proper subset, that is not equal to. So this is because I draw a line for all of the outward. It's not just this equal to. Why we have this one. Now, so in this case, we started from B. I started from B. I wanted to see if do I have all members that I have in B also in set A. Now let's start from A. So I'm going to rewrite that part so we can better see. Where we started. From B. That's why from left to right, first I have B. So that means we started to compare B first. Now I'm going to start from A and see if do I have all these members. Obviously we don't. We only have these again. And we don't have 1, 3. Yes, we don't have these 3 inside B. Is A subset of B? It's not. Is A proper subset of B? No, it's not. So this means our answer is, again, A is not equal to B. So it's same. So these two are exactly the same thing. It doesn't matter which one goes first. B is not equal to A is exactly the same as A is not equal to B. So that is the answer for part G. In the next page, example number 2, list all subsets of the given set. The first one, our set is A, and that is equal to empty set. So this one is called empty set. So A is equal to empty set, or we can write this way. This is also empty set. Now we have to list all subsets. I already did by just writing under method to write this A equal to. But first, when we try to list all subsets, we have to find the cardinality or number of elements. So finding number of elements is equal to, I can write number of elements in set A. How many members we have here inside the set? We have nothing, so that is 0. That means number of subsets is equal to the 2 to the nth power. So it's 2 over n is 0, 1. So this is the rule that we have. It doesn't matter what base is. It doesn't matter what number we have here, any number. If the power was 0, the answer is always equal to 1. So having power equal to 0, the answer is always equal to 1. So the number of elements is equal to 1, but it's asking to also list all subset. Listing that one, our answer, we already know what the answer is. It's just this one. That is the answer. Next one, part B. B is equal to set X. Inside set, we have X. Finding number of elements. I'm using n equal to, again, number of elements inside B. Because here we have n, 2 to the nth power. That's why I'm writing that part here. How many members we have here inside is 1. Therefore, number of next step, finding number of subset is equal to 2 to the nth power. 2 to the 1, that is equal to 2. Since we have to now list all subset, we always have to start from empty set. So we always have this one. That is starting part, comma. Now after that, we have to write what exactly was given for our set, which is this one. So this is the answer. It's empty set and set B. Now part C, our set is 3, 4, 5. We have how many members we have here inside. The number of elements inside C, counting how many we have here. It's 1, 2, 3 members. Therefore, number of subsets is equal to 2 to the nth power, 2 to the third, and that is equal to Z. Now listing our subsets. Starting point, always start with empty set. We should have empty set. We should have the, the set itself, whatever was given, we should have that one too. But here in this case, we have 3 members inside the set. Well, I don't have 2 subset, I have 8. Starting with empty set first and then writing each one of these members individually. I'm going to write 3, 4, 5. After you did that part, then after that, writing pairs. So 3, 4, 4, 5, 5, 3. But we're not going to repeat. So do not repeat. We have 2 of these members inside one set. 3, 4, 4, 5. We have 3, 5. So do not repeat. And finally, writing the set itself, which is 3, 4, 5. Now, how many we have here? We have total, we have 8 subsets. So this is the answer. Next one. Now here on this part, we have Y and Z inside set. Again, first step, finding number of elements inside set D or finding cardinality. That is equal to how many we have is Y and Z. So we have 1 and 2 members. So it's 2 members total. Now finding number of subset. Now we have 4. So we have empty set first. We have to write each one of these individually. We have Y and Z inside set, so writing each member individually first. Since we did, we had both of these. What is left is just now writing pairs. We have Y and Z, and that is set itself. Example number 3. What we have here is we have set that has 9 elements or members. So this is elements, or you can say members. How many subsets does it have, and how many proper subsets? The number of elements are equal to 9. Here it doesn't say what is outside, it's A, B, or whatever. That's why I'm just writing, and it's 9. Now writing, finding number of subsets. That is equal to 2 to the nth power. So it's 2 to the 9th power. Using calculator, and that is 512. Now finding number of proper subsets. So proper subset, that means we don't have equal to, our sets are not equal to, and we used subtraction. So subtract 1 to find proper subset. And this is 2 to the n to the 9 minus 1 is 512 minus 1. The answer is 511. It didn't ask to list these, but let's work on other example. I'm going to add one more here to practice for this part. For example, let's have A equal to 3, 5, 6. Number of elements inside this set. How many members we have? We have 3 members, so that is equal to 3. I cannot have a set that is equal to 9 members. It's almost impossible to write all of these, because here we have 512 and here we have 511. But instead, I'm working on another one having 3 only, to see what is the difference between subset and proper subset. The number of subset, so it's 2 cubed is 8. And what is number of proper subset? That is equal to 2 to the nth power minus 1. It's 2 cubed minus 1. So it's 8 minus 1 is 7. Now I'm going to list for each one. Here we have list of subset. Here I will have list of proper subsets. So here I have 8. So we have 3, 5, and we have 5, 3. Order doesn't matter here in this case. So you shouldn't repeat. 3, 5 is exactly the same as 5, 3. So do not repeat. We don't have 5, 3 again. So we have empty set here. Now we have total, we have 8. So we don't have this one. Now list proper subset. For proper subset, the only one that we shouldn't use is set itself. So here in this case, our set is 3, 5, 6. We shouldn't write that one.